You know the feeling, right? You're just going about your day, you glance at your phone, see that little notification, and you tap. Just like that, an app updates, and suddenly, everything's a little bit shinier, a little bit better. It all happens in just a few seconds. That bug that's been driving you crazy, poof, it's gone. That new feature everyone's been talking about, well, there it is. It honestly feels seamless, almost magical. But you know what? That seamlessness, it's probably the most sophisticated magic trick in the entire modern world.
Because that's exactly what it is, an illusion. Behind that simple tap, there's this sprawling, complex, and most importantly, intensely human process. It's a story filled with negotiation, with conflict, and just thousands of hours of work by people you've probably never even heard of.
So what is the real story here? I mean, how does some random idea on a whiteboard become a piece of software that millions of us use? Well, that's what we're going to do. We are going to pull back the curtain and show you the real machinery and the real magicians behind all that code.
Okay, so every big journey needs a map. And in the world of software, that map is the blueprint. But this isn't just about drawing up some plans. Oh no. This is about navigating a total minefield of competing priorities, office politics, and this strange, hidden kind of debt. To really get this, you first have to meet the main players, our unsung heroes. You've got the product owner who's totally focused on business value, but their goals might clash with the technical lead, whose job is to protect the system's long-term health. And then you have these specialists, like the Site Reliability Engineer, or SRE, whose entire mission is just to keep the lights on. Each one has a critical and often competing role to play.
And here's the most important part. It all starts not with a single line of code, but with a really high-stakes negotiation. You've got the product owner and the business analyst right in the middle of it all, trying to translate these vague business goals into a solid, concrete plan that engineers can actually, build.
And this is where we get to the messy truth of it all. Deciding what to build next, it's not always this logical, rational process. A lot of the time, it's a political battleground. The sales team might call in a favor to get a feature for a big client. Or maybe marketing gangs up in a meeting to push for something that'll help their next campaign. The final plan? It often looks more like a political treaty than a technical document. All this pressure leads to one of the most critical concepts in all of tech, technical debt. The best way to think about it is like a mortgage on your house. To hit a deadline, a team might take a shortcut, right? The easy solution. That's like taking out a loan. It gets you what you need right now, but you absolutely have to pay it back later with interest. And that interest comes in the form of bugs, slowdowns, and really expensive rewrites down the line. And believe me, that cost can be astronomical. Just look at Meta. They recently finished paying off almost 20 years of technical debt. It took them a grueling 4-year-long project just to modernize one of their core systems that had gotten slow and clunky. That's the kind of massive bill that eventually comes due. All right, so with the blueprint finally approved, we head into the forge. This is where ideas get hammered into actual working code. And this whole stage is this incredible dance between building things up and then, almost immediately, trying to break them down.
And you can forget that old stereotype of the lone coder in a dark room. Modern software development is deeply, deeply collaborative. A developer works on their own isolated branch of the code so they can't accidentally break anything for anyone else. And before their work can become part of the final product, it has to pass a code review, where their teammates literally scrutinize every single line. Nothing gets through without passing this human firewall first.
See, in the old days, all the testing and security stuff happened at the very end of the process, which was incredibly slow and expensive. The big revolution in the industry has been to shift left, basically to move all of those important checks to the very beginning of the process. So now, quality and security are built in from day one, not just bolted on as an afterthought. This whole shift is powered by just relentless automation. Every single time a developer submits a change, this army of automated sentinels just springs into action. Some of them scan the raw code for known vulnerabilities. Others will test the running app by actually simulating attacks. They even check for simple human errors, like if a developer accidentally left a password somewhere in the code. It's this incredible, multi-layered defense that builds trust automatically.
So what does all this really look like? Well, if the old way was all about these silos, you had these slow, painful handoffs from developers, over to testers, over to the operations team. But the new way, which was pioneered by companies like Netflix, is called the full cycle developer.
It means a single team owns their feature from the initial idea all the way to running it live for users. No more throwing things over the wall. Okay, once the code is built, tested, and secured, it is ready for launch. But we're not just, flipping a giant switch here. We are sending it through a highly sophisticated, fully automated Launchpad that's designed for two things: speed and safety.
And that Launchpad is called the CI/CD pipeline. It's basically a fully automated assembly line, but for code. The second a developer commits their work, the pipeline just takes over. It automatically builds the software, runs it through a whole battery of tests, and if, and only if, every single check passes, it deploys the code out to users, often without a human ever touching a thing.
Now you have to remember, releasing new code to millions of people is, well, it's inherently risky. One tiny little bug could cause a massive outage, so the entire process is designed around one core principle: minimizing the blast radius. If something does go wrong, you want to make absolutely sure it affects the smallest number of people possible.
And this is how the pros do it. They use a strategy like a canary release, which treats every deployment like a science experiment. You release the new version to just a tiny fraction of users. These are your canaries in the coal mine. You watch the data like a hawk. If everything looks good, you gradually roll it out to more people. If not, you slam on the brakes, and only that tiny group was ever affected. But the journey is not over when the code goes live. In fact, in a lot of ways, it's really just beginning. Welcome to the final stage, the 24/7, never-ending vigil to keep the service online, reliable, and running smoothly. But this constant, around-the-clock vigilance, it comes at a huge human cost. The pressure to maintain perfect 100% uptime is a massive cause of burnout in the industry. And just look at this number. More than half. Over 50% of the people building and maintaining our digital world say they feel the effects of burnout from chronic stress. That right there is the hidden price of all this seamlessness. And burnout isn't just feeling a little tired. No, it's a debilitating syndrome with real devastating symptoms. We're talking about extreme cynicism, a total loss of meaning in your work, chronic exhaustion where you just never feel rested, and this pervasive negative self-evaluation, this feeling that you're just not good enough. This is the real toll of our always-on world. So how do the best companies on the planet manage this kind of pressure? Well, they completely changed their relationship with failure. Google, for example, has a principle of blameless postmortems. When something breaks, the goal is to start from one simple, powerful assumption. Everyone involved had good intentions. And that shifts the focus from blaming people to fixing the system that allowed the failure to happen in the first place. Netflix takes this idea even a step further with this wild, proactive philosophy they call chaos engineering. It's built on the idea that the absolute best way to avoid a catastrophic failure is to fail constantly, but on your own terms. They literally break things in their own live systems on purpose, just to find weaknesses before some random event or an attacker can. It's all about building resilience by embracing chaos.
So you see, the real story of the technology we use every day isn't about flawless machines at all. It's a deeply human story of collaboration, of compromise, and incredible resilience. It's about this whole network of unsung heroes who manage this mind-boggling complexity day in and day out. Which kind of leaves us with one last thought. If failure truly is our best teacher, how can we all get better at actually learning its lessons? How do we build systems, not just technical systems, but human systems that are designed not just to succeed, but to learn?